Today you'll see that the way you imagine the solar system might be completely wrong. It's very likely that if you Google the solar system right now, you'll see the sun in the middle with a bunch of planets orbiting around it. A nice composition, right? It looks like that drawing of the atom we're used to seeing, all the planets close together, more or less there, just a little smaller than the sun. Now, I have two pieces of news for you, and of course, one is bad and the other is good. Because whenever there are two pieces of news, it's never two good ones, right? But let's get into it. The bad news is that that's just an artistic representation. The solar system is very different from that. The good news is that today, we're going to make our artistic representation a little closer to reality. And you, yes, will get a sense of the size and distance of things, which is much greater than we imagine. And because of that, it doesn't fit in a simple drawing. The drawing would need to be huge with tiny celestial bodies. So, to make a more fun solar system representation for a science fair or project, since it's really cool, we're going to use a roll of paper, the kind they use in supermarkets and little stores, right? And here we're going to draw the celestial bodies of the solar system at a distance proportional to their real distance. Unfortunately, we won't be able to draw their diameters to scale as well, because if we were to do that, when we compare the sun with Mercury, for example, the sun would be a giant ball and Mercury just a tiny speck. So we'll have to draw the size of the spheres more or less imaginatively. But the distance, yes, it will be perfectly proportional. Let's start here with the sun, which is the largest body in our solar system. And we'll use it as a reference at the beginning of our scale, in our drawing of the solar system. After all, it's called the solar system, right? One important thing for us to know is that the distance between the celestial bodies in the solar system is usually measured in astronomical units, not in kilometers. Because from Earth to the Sun, we have about 150 million kilometers. I say about because this distance varies a little, and it will always vary between the planets. The orbits are not perfect circles, they are slightly elliptical. So, to make calculations easier, astronomers use this distance between the Earth and the Sun as an astronomical unit. So one astronomical unit is 150 million kilometers. When talking about, for example, the distance to Jupiter, we don't say it's 6 zillion kilometers. We say it's 5.2 astronomical units. From that, we created our own scale here, because this roll of paper is 30 meters long. So that we could reach Pluto, one astronomical unit in our system will be 64 centimeters. So, that's the scale. And from there, we'll know the true proportional distance of each planet. The first planet, which is the closest to the Sun, and which I'm going to draw, is Mercury. It's the smallest planet in the solar system. It's just a little bigger than our moon. And it has this kind of dull color. Nothing special about it. Mercury doesn't have any moons, and it's the fastest planet of all. Its year, that is, one orbit around the Sun, lasts only 88 Earth days. And do we have to say 88 Earth days? Because when we're dealing with other planets, those planets have different days. So let's use our day as a reference. The next planet on the list is Venus, which is about the same size as Earth, and, incredibly, even though it's farther from the Sun than Mercury, it's the hottest planet in the solar system, because it has a strong greenhouse effect. In fact, it's a planet that has sulfuric acid rain. That's why we want to go to Mars, not Venus, right? Venus also doesn't have any moons. And an interesting thing is that it rotates in the opposite direction of most planets. So, there the sun rises in the west. Now it's time for our beloved Earth, which I'll draw with a bit more care, because of the affection we have for our own planet, right? Earth has only one moon, which I'll draw at about this distance here, just so we don't leave the poor moon out. If we were to do it precisely, the way we've been doing with the other planets, it would be a distance of about 1.5 millimeters. Maybe the most special thing about Earth isn't humanity, okay? What's really special about Earth is that here we're at a distance from the Sun, where it's possible to have water in all its physical states. So, we have ice, there's liquid water, and there's water vapor, which allows us to have rain, glaciers, seas, and everything else. And because of all this, it's easy for us to have life here. And as I'm unrolling this, I just realized I'm using the same roll we used for the tests that already has some things drawn on it. I think I'm going to have to switch rolls. For artistic reasons, I'm going to imagine that this ugly patch I made represents the space junk we're leaving around Earth. Namely, these satellites that don't work anymore. They're no longer useful. It's pieces of spacecraft and everything else that stays in orbit around our planet. Mars might be the first planet where humans could live outside of Earth. It's also known as the red planet because its entire crust has a lot of iron-rich materials that are oxidized. In other words, Mars is basically a desert of rust. It's a planet slightly smaller than Earth, with about half the diameter. It has 2 moons, though I'm not sure that's really an advantage. Honestly, I prefer Earth. Do you think Elon Musk will grab my foot in the middle of the night? But what's really interesting about Mars is that it's the last rocky planet. These 4 we've drawn here are solid planets. You can actually land and set foot on the ground. From here on, you'll see that things start to change. Halfway between Mars and Jupiter, there's the asteroid belt. It's a bunch of irregular celestial bodies. Some can even be a few kilometers in diameter. It's even hard to talk about diameter because they're kind of crooked, with the exception of the one that's right in the middle, which is Ceres, our first dwarf planet on this scale we're drawing here. This dear little planet here would be worth a whole story on its own. Ceres is pretty spherical, but it's small. It's about a quarter the diameter of our moon. When it was discovered, astronomers thought it was a planet. So, at first, Ceres was considered a planet. But later, Ceres was downgraded. It was considered an asteroid because it was right there in the middle of the asteroid belt. But in 2006, Ceres was redeemed. It was considered a planet again, but a dwarf planet, a smaller planet, just like Pluto. So, right here in the middle of the way between Mars and Jupiter, there's a little planet called Ceres. Even though it's small, the mass of Ceres is about 35% of the mass of the entire main asteroid belt. Finally, we've reached the giant one, the biggest of them all, the planet that is 11 times the diameter of Earth, which is Jupiter. It even has this spot down here, this kind of whirlpool, which is a storm that has lasted more than 100 years. Jupiter is a gas planet. That means we can't exactly step on it. It's made mostly of helium and hydrogen. It has rings, but they're really faint. And it has a whopping 75 moons, I'll confess to you that every time I look up this number, it gets bigger. New moons keep showing up around Jupiter. Some of them were discovered by Galileo. There were 4. And they're the first moons discovered beyond Earth. That's why we call them the Galilean moons. Isn't that crazy? Here in my hand are the 4 rocky planets, all very close to each other. Jupiter's a whole different story. It's way out there in the middle of nowhere, several astronomical units away. Now it's time for the star, the most handsome and stylish planet in the solar system, because it's the only one that's adorned with truly impressive rings. That kind of disk around Saturn is really beautiful. But if we looked at it up close, it's nothing more than a bunch of dust with some small rocks. From afar, it looks beautiful, but up close, it's sparse and diffuse. This planet is gaseous, has 53 moons, and is the last we can see with the naked eye. Beyond this, a telescope is needed. For perspective, consider the distance between Saturn and Uranus, the next planet. Here on our scale, it's 6 meters and 16 centimeters. It's farther than Saturn is from the Sun. Uranus is also known as an ice giant. It's made mostly of water, methane, and ammonia. It's a planet that has 13 little rings. They're much less visible than Saturn's. The little guy has 27 moons. And one thing that's really different about it is that the planet spins kind of sideways. It's as if the tilt we have on planet Earth was much greater. So it kind of rolls along its orbit. Once again, we're going to have a bizarre distance to the next planet. On our scale here, it's almost 7 meters. Neptune is practically Uranus's twin brother. It's also an ice giant. It's also a planet made mainly of gases. It's practically the same size. It's also a blue planet. It also has rings. But it has a little fewer moons. There are only 14. If I had to describe it, I'd say it's kind of a gloomy planet, right? Look how far it is from the sun. It must be really cold and kind of dark there. Theoretically, the planets of the solar system end here. So we could, in a way, already finish our list. But there's an emotional reason that makes us keep going. When I learned about the planets in school, it's very likely that you learned it that way too. Pluto was the 9th planet. It was right there at the very end of the solar system. And suddenly, in 2006, it was decided that Pluto was no longer a planet. Pluto was downgraded to a dwarf planet. Why did they do that to the poor thing? What did it do to deserve that? It didn't do anything. But the truth is, it's not exactly at the very end of the solar system. There's a lot beyond Pluto. There's a lot near it too. And Pluto was a really weird planet. First of all, it's really small. It's smaller than our moon. It's 2/3 the size of the moon. And there's more. Pluto has its own moon, Karen, which is nearly the same size. Pluto's orbit is unusual and sometimes brings it closer to the sun than Neptune. There's also one more technical detail. For planets to really be considered planets, as they go along their orbit, along the path they make around the sun. They clear everything out because the planet's gravity pulls objects in, causing them to fall onto the planets. And the planets that have clear orbits, Pluto isn't quite like that. And the last thing, which is the most complicated of all, it's that Pluto is in a region of the solar system called the Kuiper Belt. It's a region that's pretty far out there, where there are other dwarf planets that are very similar to it. So over time, it was discovered that Pluto had several siblings, a bunch of little planets. So in the end, if Pluto hadn't been downgraded, we would have to promote a bunch of other dwarf planets to full planet status. Then things would get confusing. But this little planet lives in our hearts, especially because Pluto has a heart. When I was a kid, Pluto was just a white spot, because that's the image we had of it. We knew the planet was there. There was a terrible picture of it. We also know because of its orbit, because of the way it moves, several calculations were made to know that it's there. But we didn't know exactly what Pluto's texture was like. Then in 2015, a probe called New Horizons. It passed very close to Pluto, and it took the wonderful photo of Pluto that we know today. And it's known that it has a kind of white heart shape. Just so you have an idea of how far Pluto is. Pluto is, on average, 39 astronomical units from the Sun. In other words, 39 times the distance from Earth to the Sun. It's really far. But the solar system doesn't end here either. It goes much further, beyond the Kuiper Belt. We still have the Oort cloud. That's where most comets are born. And that's absurdly far away. Just so you have an idea, this Oort cloud, it stretches from 2,000 to 100,000 astronomical units. That means we would need a much bigger roll to represent it. Getting to Pluto, I think that's already pretty cool. Wait, don't leave yet, because now comes the coolest part, which is when we stretch out this big sheet of paper here and see the difference, to understand how big our solar system is. And that's not even counting the Oort cloud. I'm going to secure the sun to this lead bar from a submarine, so this thing doesn't start moving around. So we're going to start with the sun. Mercury, Venus, Earth, Mars. They're the closest to the sun, our backyard of rocky planets. From now on, things start to get a little farther apart, and that's where it starts to get surprising. Here's Ceres in the asteroid belt. Jupiter will only show up here. It's absurdly far. Saturn is already way out in the middle of nowhere. Wow. Be honest, did you think Uranus was that far away? Neptune, the last planet. And Pluto, our favorite planet. It's way too far. Proportionally, it's way farther than I imagined. Don't forget to give that thumbs up. Deal? What a shame. In this video, we pretty much skipped the sun, so if you want to know a little more about our star, we once made a lamp that turned out beautiful, but we also explained a lot about how the sun works. Go check it out